relative atomic mass, or in short it is called RAM. This is again is a very confusing term, very much related to or very much closely associated with atomic mass, mass number and average atomic mass. See, relative, when we uses the word, it is in respect to or with respect to some particular constant, or it is in relation to some particular constant. So now, in order to define the masses of these subatomic particles like protons, neutrons and electrons and so on, what we did is we gave first a term. So to define masses of subatomic particles, the term U, which is called unified mass, was given. And we defined that 1 U is equal to 1/12 of 1 C12 atom. This we already know. Now after defining this term, we always wanted to now compare the masses of the atoms of the different elements with this unit. So for this, what we did is we started comparing the masses of the atoms of the different elements with this unit. So our unit is 1 U, unified mass, and when we placed hydrogen against it, what we found that it is almost similar in the atomic mass, so we called hydrogen's mass to be 1 U. Then we have placed helium, or when we compared the helium's mass with this unit, what we found that it is 4 times of this unit, so we call it 4 U. Similarly, carbon was found to be 12 times of this unit, so we call it 12 U. Nitrogen was found to be 14 times of this unit, so we call it 14 U. Similarly, oxygen was found to be 16 times of this, we call it 16 U, and so on. So this is how we define the atomic masses of all possible elements we are having in the nature, and their masses actually are with respect to the unified mass unit. Therefore, all atomic masses are relative atomic masses. Remember, because they are with respect to this unit, so this is how we have compared them, and that is how they are called relative atomic masses.